Welcome back, apes. It's Mr. Grop again. I am so excited today because we finally get to cover a topic that I know you really care about. So buckle in. We will be studying dirt for the rest of the week. Soil comes from the bedrock that is underneath or sometimes around. As it gets beat up or weathered, new particles stack on top that become what we call dirt. So the parent material in this case is the rock. Here you can see that half of what we call soil is actually just the pore space, the air and the water. Now, in addition to a small percentage of organic material, we have what's left over being the minerals that came from the bedrock. Not all bedrock is the same, so therefore not all soils are the same. The most important factor determining what type of soil you have is climate. Remember that climate is the temperature and precipitation averaged over 30 years to help us also define a biome. As you can see from the diagram, most biome soils differ both in thickness and in fertility. Now, it might seem surprising that tropical soil is considered infertile, whereas desert is considered fertile, but it really has to do with where the nutrients are located. In a desert soil, the nutrients are compact near the surface within that first 3 centimeters. In a well-weathered tropical soil, the nutrients have all washed down to the bottom, almost 3 meters deep into the ground. You've probably heard environmentalists complain about the destruction of the tropical rainforest. Let me explain why it's such a big issue. In other parts of the world, agriculture isn't always as developed as in the US. They are looking for the cheapest and easiest methods. So that involves things such as clear cutting, where they literally just cut down everything in their path. They will often leave large patches of trees intact so that people in the surrounding areas don't even realize that deforestation is occurring. They also use a method called slash and burn, where they cut and burn the rest out, leaving the ash behind as nutrients. The problem is that when you remove all that vegetation, which had long roots that could reach down to the bottom of the well-developed soil, anything that you try to plant is going to have short roots that are not able to reach down. The process of nutrients getting pulled to the bottom of the soil is called leaching. With slash and burn and clear cutting, there's enough nutrients for one growing season, but the next year, that land becomes a complete waste. So the thickness of tropical soil tells us that not only is it well weathered, but that it is also developed. Soil takes time to form from the bedrock. And as the pieces of bedrock get smaller and smaller, they also accumulate down near the bottom of the soil, giving the soil the appearance of having layers. So we can classify how developed a soil is based on what its layers look like and what they're comprised of. If you take all the layers of the soil from the surface down to the bedrock underneath, you have defined what we call the soil profile. Each layer within the profile is actually called a horizon. And if you look at the diagram on the left, that is a mature soil because it has 4 different horizons. The one on top is called the O horizon, which stands for organic matter that is found at the surface. Remember, we also call this material biomass. Horizon A is also called the topsoil, and we'll talk more about that in just a second. Underneath, you find Horizon B, which is called the subsoil. It's mostly clay that is washed down or leached from the topsoil. Clay is the smallest particle, which we'll learn about later on this week. Underneath Horizon B, or the subsoil, is Horizon C. It does not have an alternate name, and it's simply just bedrock that has begun to weather in its earliest stages. So if you think about that for a second, the stages don't form in the order that is typically shown. The correct order is usually horizon C, then horizon A, and eventually horizon B finishes the mature soil profile. Let's go back to horizon A for just a second because it's the one that we interact with and need the most. You can usually tell if a topsoil is fertile or healthy because it'll be dark. And that darker layer is a result of the organic material that has decayed in it. We actually call this humus. And no, it's not like hummus that you eat. Also understand that topsoil is the most beat up or the most weathered. And that's simply because it's the layer that is exposed to wind, water, ice, and so on. I think we'll conclude today with this diagram showing, once again, the importance of the topsoil. This is where roots take hold. This is where critters burrow and live and decompose. And this is a very important place for the nitrogen cycle. This is where bacteria convert nitrogen to an organic form and uptake occurs into the roots of the plants. Nitrogen is one of the most important ingredients in soil fertilizer. And tomorrow we will look at what happens when that balance of nutrients gets thrown out of whack. We will also look at how soil degrades over time due to natural agents and what we can do to bring it back to life. Well, I leave you today with this picture, which is Mr. Gropp having some fun down on the banks of the Ohio River in southern Indiana. And I encountered a very special type of soil that day. I was unaware that we had this, but sure enough, I got into some trouble with quicksand. It's a bit of a long story, but the short version is I ended up buried up to my knees in quicksand, and thanks to my background in earth science, I was able to get out safely. I will tell you that it was not really that much fun, contrary to the cute expressions of my daughters. Okay, well, I hope everybody is safe and that e-learning is tolerable, and I will see you again tomorrow.
Things gonna happen for me. I'm Joe Dirt!